Hey, hello guys. So, short forward, hopefully short, because the video went way too long. I want to show you the design process of a part, of a very simple part. So I thought it would be a fast video, and it became a long video. So this is the finished product, which we are going to design in the video together. And since usually almost nobody watches video till the end, which is on all channels the same, maybe on my especially so. I just wanted to say give you a short final product which really feels nice and looks nice-ish. And I think this whole process, having an idea on paper, then putting it in CAD, putting it on the slicer, getting it printed, and having the part in your hand, that's really something highly satisfying. And I would really recommend trying this out, even if a CAD software really looks scary, big, and complicated. It's something you should at least try out. But maybe we can do videos in that direction if somebody is interested. Yeah, enjoy the video, enjoy the journey. It went on a little bit too long, so maybe do it double speed or something, or skip a couple of parts which are more boring. So I want the whole thing from the side, which will also be our sketch, should look about this. I need a small brim, then I finish here. So there's some measurements which are quite clear, which I already took and remember. So it's like 20 millimeter, 2 centimeters or 20 millimeter in that direction. And now this distance is 10 millimeters because we have to fit the spacers here, which are already glued on the parts. So that's 1 centimeter or 10 millimeters. I think this is like 5 millimeters thick. Probably within tolerance. So that's about 5. And if it's not coming clear, it should in the afterward it should look somewhat from the front like this. We need 2 holes here, so M4 holes. This would be the finishing edge here. So we also need the distance here from this part, like from there to there, and from there to there. So that's something we also need, but that I will measure off screen, and then we need 7 of those. We need 1 for the right and 1 for the left side, because I didn't do it symmetrically. And I can't actually read my handwriting either, so don't worry about that. That's why we're going to the computer, or part of it, because we of course need something in 3D. So I have to measure this here, but it's a little bit more complicated, and hopefully it's halfway symmetrical, so that we don't need like to do a dozen different parts. But I think it should be, yeah, that the whole house is like from 1929, so there's no real straight angle here in the whole house. Yeah, it's not as bad as the neighbors. So yeah, I'll finish measuring, and then I'll take you guys into onshape, or onshape, how it's called. And let's do a little bit of CAD. Yeah, I'm almost qualified. So guys, we're here at the final stage of our table project after we made the edge and scadified almost everything. We need like a finish for the edge here. And since we have a quite significant gap here, we are like tools, screws, build plates, everything else could either get lost or just drop behind the table. We need to do like a little bit of a edge finish, finishing edge, and scale this integrator there. And I don't think that's a part that already exists, so we are going to develop it, and should be pretty easy. So I guess that's actually a quite good thing to take you guys into onshape, into Bambu Studio, and just show you the magic. But as always, before we go into the computer, paper is still king. Let's do a short draft here and measure a little bit. So guys, since I already did it, it should be a little bit faster, and this try Over here in OneShape, I'm familiar with CAD software, but not so much with OneShape itself. In like 20 years of experience with Solid Edge and NX, but I'm not primarily a CAD designer, so I'm more on the software side of things. So, but yeah, OneShape offers like half a year of trial period, which is quite nice. And you actually can use it totally for free if you are willingly to have all your stuff public. But that's a downside there. And of course, CAD software, once you get into paying, is quite expensive. One big advantage of OneShape in this regard is that it's web-based, so if you don't have a fancy graphics card or anything, you don't have problems there. You don't need a local installation. You can do it on basically any hardware that can run a modern web browser, so you're pretty open there. You could do it on a cell phone, maybe attach a monitor and a keyboard and a mouse, and you're pretty much ready to go. So let's start editing from scratch. That's like if your internet is really slow, it's probably not an option, but yeah. So this is basically a sketch-based system, very similar to Solid Edge, which is pretty easy if you maybe are already knowledgeable with drawing, technical drawings or something, or you have run a 2D CAD system before. So we always start with a sketch, select a plane for a sketch. Or what? Forgot one important thing. This actually offers you variables. And if you have that option, you should always use them. Because yeah, it's it's just so much easier if you have variables. You have to do any change. The measurements here. Whenever you are later want to use that value, you just have to use the hashtag and the name. And I'm a fan of using speaking speaking names. Okay. Just like, yeah, you have to always to think about what do you want to do like in 10 years. If you have to return to this thing in 10 years, will you remember anything if you just name him like X, Y, Epsilon? And actually, they are hierarchically. If you want to reuse one of those somewhere in between, you absolutely have to go. You have to reorder them, but you can just drag and drop them in their orders. If I would say like, if I would want to make them rely on each other, then you have to always take the hierarchy into your head. And have them have them in mind. Let's see. You can actually define the variables one at the point where you need them as well, but it's probably easiest to start um, We have very many returning values here, so that makes it a little difficult here. So let's go on our sketch. I I promised you it would be fast, but no, it's taking long as well. We selected our plane to make it a little bit easier. We go into go here to go into the orientation. How we orient it is actually totally unimportant in this case. So we have our basic design with like one thing here, here. And as you can see, like here, I'm defining this. This is parallel to this one. But already has some measurement in it. Actually, it's black that shows us. Fix. This is what this is. All. Oh, actually, this is the height. Find our current thing here. Um, 8. So and we need this here. This is one. This one is 90 actually. I actually did wrong in my last variable. It 9 millimeters. Not unified. So probably have it like at the longest part I have 9.5. Oh no, wait. No, no, it's 10. So. Sorry. My mind was wondering. So we have like 90 in total, but like 8 of those is 8 of height of the plate. So yeah. So got back in the sketch. Need automatically. So sketch is finished. Now we are going with the extrude to actually make our thing. And here we just go with the actually we have to go with the usually would go with the length, but I have a special thing here, so we have to add the chamfer so we can overlock the part. Here create this that we can interlock the both sides of the part, and hopefully my prototype will look okay. this. Or we had to go with a because now we have this little bit sticking out and can go on the other side. And now I want the same here, and I actually did a workaround. I'm not quite sure if this is the best way to do it, but just putting a shell on here and do this. Here, dort dann wir. Always a little thing where I'm not quite sure to make one like it. As you can see, we have like have it a little bit hollowed out now. Probably is below the resolution of the printer. I have to see. Maybe it does take some additional time. But yeah. So now we need to place our holes, our M4 holes. Yeah, that's why we had to put the 1 millimeter, 0.1 millimeter here, get it to the exact length. So now we need to construct our boreholes, or we are going to do a sketch as well. This one. Oh. Comment. Distance. Too tight. Need and as you can see, from now went from blue to black, so it shows us that the measurements are. One thing I forgot, we need to construct points for a whole function. Points. So now we constructed those points. Hole. Yeah. Or actually there. Then we have rolls. Yeah. Now that's actually our finished part. Then. Way around. So, but now we want to make a test. Or if this well, let's say I already did that part. Was a little bit different. We want to test print this, so we can export. Yeah, the export here. We have to give it some name. And yeah, the bambu slicer would like to have it at step. Print is already running because I did this beforehand. Just a little bit different with the hole there. And let's just go to the studio and see what we did there. The thing we did for the test, we made it much shorter, like 3 centimeters, so we wouldn't print for an hour and have a broken part afterwards. So this is shorter version I made before, and I think I have to I'll do the other holes there. So my test primarily to see if the holes are actually in the right place. That's what we want to test here. But this kind, we have only 6 grams of material and like half an hour to print this part. Actually printing 2 of them, one on the Mini, one on the A1. Trying out the orientation, the slicer. Did recommend, like with this button here, you can give the slicer an option to put it, and he wanted to do it that way. I'm not quite sure if he will do the same with the longer thing. We'll have to see how they fit and then decide if this is the right way to go. But yeah, after those prototypes are finished, and if they fit, then we'll just try the same with the full length with 2 parts, and do the 5 additional parts and the 2 end parts on the Mini parallel, and then we'll see if it all fits and if it's looking as we want it to look. So here we have our parts. This one is from the Mini, as you can see by the surface here. The other one was printed on the back. You can see the automatic system was a little bit right, because it made the holes nicer on the Mini orientation. In the end we'll probably go after speed. Actually made it a little bit hollow here, but that's probably taking us a little bit more time overall. So for the pure design, and probably costs a little bit of material. But we are still not quite there with the holes. So we have it like, this was the first test with 8 millimeters. That is a little bit not enough, and now we are almost the same distance off, so we have to go with 9 millimeters, I guess. Let's just take a look on the wall, that we get a glimpse how it should look if it's finished. Yeah, and we have like a little bit of tolerance here, as I measured. So like on the one side, it's, I think to this side it's almost down to 9, and there's 9.5. So we have to go with a medium value, and then look if we go on the top or go in between. This is something I'm still deciding. Probably have to glue the things on anyway. So yeah, see, this is my previous design where we had the holes where we have space for the screw heads. Yeah. So we do the final design, put 2 parts on the slicer and see if they actually, if the measurements from the length here are fitting, but it should be with 24. Yeah, that should be okay. Let's see. So this is going absolutely in the right direction. Cat approves as well. So yeah, let's print 5 more and then glue them together. It's not necessary to glue them, but I think that, well, I have to see. Maybe I won't. I'm quite sure yet, but probably to showcase it, it's better. And for the screwing, this has also worked out quite good so far. Like not having to. Yeah, but this one's probably easier than with the round ones. So maybe gluing is not really a necessity here. Yeah. We'll see. That I have to showcase it before it's screwed down. Gluing is probably necessary. So guys, this is how it will look in a couple of seconds. I think I'll just skip the glue and go directly to screw. Yeah. Somehow I miscounted and I made one too much, but yeah. Who cares? It's good for the video intro. Guys, I should have glued it before I screwed it, I guess. It went a little bit crooked down there. overall I should have started the whole project here and not on top, which of course was a little bit due to the wall mounts for the AMS lights and such, but yeah, it's finished. It actually, it feels great, so that's probably not going to touch it that much, but it feels pretty nice. Yeah, like here it's especially crooked, so. And had I glued them together before I screwed them together, I probably would have been better able to adjust a little bit there. We would have also needed to take out like 1 or 2 millimeters on the total length, but it could all be due to like warping and tolerances overall. Yeah, the end part I have to do it a little bit shorter, both parts, to make it fit quite right there. Yeah, but this video is finished. It has been much longer than I intended it to be. If anybody managed to watch it till here, I hope you enjoyed the journey. I think overall this whole process of imagining something, designing it in CAD, and then printing it, that's really, it is really something very special, and I would highly recommend trying that out if you are in the hobby, because yeah, it's much more than just selecting something from Markerworld or Printables or wherever and putting it on the slicer and printing it out. It's really much more satisfying overall. Even if it does not look as good as you thought it should, but I think like here on video it actually looks quite okay, and if I'm far enough away, it should be okay as well. So guys, thank you very much, and see you soon. Bye bye.